All right, all right, all right. Last one. Parent-teacher conference over. Time to finish your video. All right, we're on the last part, which is part B with the calculator. And so that's the with calculator section. And so we're going to be using a calculator to help us and do these word problems, part 2. So that was modeling day 2 stuff. Ferris wheel at Disneyland. Woo! Circle the diameter of 150 feet. So let's go ahead and draw that. It's always good to draw it. So don't forget, ooh, that's a pretty good circle. So if the diameter is 150 feet, so diameter, so the radius is going to be half that, right? And so 150 divided by 2, and so is that 75, I believe? 150 divided by 2. Nice. So we got 75 here and 75 here. Brilliant. Okay, and then so it sits on a 10-foot tall platform. Awesome. Making its overall height 160 feet. So now we have our maximum and our minimum already. What? Nice. Okay, so then it completes one rotation in 9. Completes one rotation in 9 what? Okay, we'll say seconds, I guess, maybe. Awesome. Okay, so then we're going to do one complete cycle. And the rider starts at the lowest point. So we're going to start down here at our minimum, which is 10 feet. And so this is going to be feet in our measurement here. It's going to be our height if you want to really be specific, which is always good on a test. So height in feet. And so 10 is our minimum, and then it goes as high as 160 feet is our maximum. Nice. So it looks like 9 seconds. So we're going to go from 0 to 9 seconds. And so that'll be our time in seconds here. Awesome. So then we're going to start off. It says completes one rotation, assuming the rider starts at the lowest point, not the highest point. Cool. So then we're going to start down here, and we're going to reach up to 160 feet, and then after 9 seconds, we'll be back down there at 10 feet. And so there's a really nice looking graph there. So half of 9 is 4.5. Beautiful. Okay, now write the equation, cosine equation. So the radius, of course, is going to be the amplitude, right? And so we figured out the radius is 75, which means that our amplitude is 75. Nice. Okay, they gave us our period is 9. Awesome. And then we also want to figure out the midline. So the midline we are going to have to figure out. And you can do it in 2 ways. You can eyeball it, 160 minus 75. Or you can do the maximum plus the minimum divided by 2. Right? So that would be 160 plus... Ooh, whoa. So yeah, the maximum is 160. That's right. So 160 plus 10 divided by 2. So that's 170 divided by 2. And now let's see, let's show you both ways. So 170 divided by 2 is going to give us our midline of 85. Or you could have done the maximum 160 minus our amplitude of 75. And that would also give us 85. Nice. So then we need that to write our equation. And so our midline is 85. Beautiful, not too bad. Ace it on the test. Okay, so the equation, it is going to be an upside down cosine here and no phase shift. So y equals a negative. Our amplitude was the same as our radius, 75. Cosine of, remember it's 2 pi over the period, so 2 pi over 9 seconds. Sorry for this random color discoloration. New board, True Touch likes to mix up my colors on my smart board system. But that's okay. So 2 pi x over 9, and then awesome. And then that's our period, and then plus our midline 85. Bada bing, bada bing, bada boom. Did you get that right? Remember to pause me. Try it on your own first. Don't just copy down. Pause me. Okay, so part C, what is the height of the rider after 3 minutes? Oh, I was supposed to say minutes. Okay. So 3 minutes would have been a lot better, but I changed it to seconds. Should we change it to minutes? Okay. No, yeah, come on. So let's go and fix that there. So that was supposed to be minutes. Awesome. So we'll change that everywhere to minutes. Now that we read the other problems. There we go. Okay, so what is the height of the rider at 3 minutes? Well, 4.5 minutes is about up here at the top. So it'll be a little bit less than that, maybe 150, 140. So we just plug it right into our equation to figure out that problem. In fact, we might graph it with our calculator, make sure we did it right. And at what time or times is the rider at 60 feet off the ground? Yeah, let's just use our calculator to make it easy on us. So we're going to go here to our calculator. We're going to go to y equals, and we're going to go and type in -75 cosine of 2. We want to do a pi and then the x, and then divided by the 9 minutes. There we go. Just to put it all together easy. Plus 85. Now we can graph it. Definitely not going to work because we need to set our window. So we look at our graph, our minimum. So let's do the y values first. That's going up and down on the Ferris wheel. So our minimum was 10. So maybe we'll just start off at 0, give us a little barrier there on our graph when we graph it. And the maximum was 160. So we could even go up one more to 170 just to show how high our graph goes. And then our minimum was at 0 seconds, and our maximum was 9, but we'll go to 10. And so that should help us graph this okay. Nice. Awesome. So we want to know what is the height of the rider after 3 minutes. So we would use second calc, and then value, and then that's just basically plugging 3 minutes in for x. Right here is what we're doing. So we're plugging in 3 minutes in there for x is what we're doing when we use the calculator and do x equals 3. So that gives us 122.5. Nice. So we've got 122.5 feet. Beautiful. Now this next part, yeah, Isaac, Mortensen. So he said we could, so at what time or times is the rider at 60 feet off the ground? And so 60 feet, right? Well, our midline is 85. So 60 feet is going to be lower. And so if we actually put in our calculator y equals 60, it's going to give us those times if we mark off the intersection, right? It's going to give us, if it lets me, that's it. It's going to give us those times there at y equals 60. So let's actually go to our calculator now and do that. So go to y equals and go down to 60, and then boom, look at that. And then you're going to go to trace, and you're going to go ahead and go down to about where it is, and you probably get on the test even right if you even just got really close, which is like 1.8, maybe 1.7. So at 62, 57, so yeah, maybe 1.75 probably. But we can do closer. Let's do intersection. So we're going to go second calc. We're going to go down to option 5, which is the intersection. And we're going to push enter 3 times. First curve, second curve, guess. 1.76, excellent, is where one of our times is. So at 1.76 minutes, we're going to be at 60 feet high. Let's write that down. So 1.76 minutes. There we go. Okay, then we'll go back to our calculator, and we'll go and trace again. And so we'll go and trace over there. Going down the roller coaster. Okay, whoa, too far. Oh, cool. Okay, 7.23 is probably right. That looks spot on. But just in case, we'll do second calc. We'll do option 5, intersection. And we'll go enter, enter, enter. And so our intersection is at 7.23. So 7.23 minutes is also where we are 60 feet off the ground. Beautiful. Okay, so then we'll take a look at number 2 next. Doing good there for time. Okay, so number 2, this is also going to be similar on the test. So let's take a look there. So let's see here. So we're looking to do the amplitude and period for part A. We're looking for the maximum and the minimum, right? Now I know this didn't say this on your test. There's quite a few things I'm doing now that we've added to your practice test for next year. Sorry for those students 2020 in February. Sorry. But we added that on there as well as on the axis. Let January be. Blah, blah, blah. We also took off part E, so don't freak out. We also took off part E as well. Cool. Okay, so then we're going to look for that hours. So in Finland, Helsinki, the daylight hours registered for the first of each month are represented table below in hours and minutes. So we want to find the most hours. So we're looking here at 1820 maybe. Nope, July looking like, so 1850. And so when we say 1850, we're saying 18 hours, right? And 50 minutes, and we do have to convert that to a decimal system. So that means we have to take 50 and divide it by 60 and get a dot something for our maximum, okay? Because we're trying to convert into a decimal system that we can graph and make an equation out of. So we're going to take 50 minutes, we're going to divide it by 1 hour of 60 minutes, convert that into hours, and so that's going to be 0.833 hours. So 18.83 hours. We're converting it all into hours, or we can convert it all into minutes, but let's stick with hours. Cool. So that's going to be our maximum, right? That's going to be how many daylight hours we have. So that's our x-axis and our x and our y value, right? And so don't forget that January is 1, 2, 3, 4, so forth. And so July will be 7, x equals 7. And y equals 18.83. Cool. Okay, so then we're going to jump over to the minimum. And that's probably looking like January. So January will be x equals 1 for our x value. And then our y value will just be 6. Nice. Okay, so we're using our y values. Remember that amplitude, that's what we're trying to find next. So remember the amplitude is how high up and down it goes. And with our maximum minimum, but those are y values, right? Y values. So we're going to use the y values, the times. And so to find the amplitude, remember, it's maximum minus the minimum divided by 2. So we'll do the maximum, 18.83, minus the minimum, 6 hours, divided by 2. So we'll use your calculator there. We're going to go 18.83 minus 6, push enter, divided by 2, gives us 6.415. So that's going to be our amplitude, 6.415. Amplitude, 6.415. Beautiful, because that's what this equals. Nice. Okay, there we go, 6.415. Then next, we're going to find the period, and the period is going to be actually a lot easier to see, because after July is 7, then August, of course, is 8, September is 9, October is the 10th month of the year, and then 11, and then 12. Nice. So there are 12 months. So then our period will just be 12 months. So those are 2 answers kind of squished in there. Awesome, for the amplitude and period. Now write the cosine equation. So in order to write the cosine equation, you also have to have the midline of our y values. And so the midline is the maximum plus the minimum. So a little bit different there. Maximum plus the minimum. And that's divided by 2. And so this time we're going to go ahead and take 18.83, and we're going to add it with 6 this time, divided by 2. And so let's see what that gives us. Minus 6, enter, divided by 2. So that's going to give us, what? Oh, we forgot to add, sorry. So 18.83 plus 6, because the midline, we're adding the total, dividing by 2 to get the middle. There it is. So 12.415. 12.415. Nice, nice. Okay, so that's going to be the midline, so that goes on the end. So we'll leave it there on the end. So now we do f of x equals the amplitude, which we figured out was 6.415, because we did the max minus the min divided by 2, times, then we do cosine of our period, which is 12 months. So 2 pi divided by 12. Then here's the tricky part. So do another parentheses. X is actually going to go here, 2 pi x over 12. And then we have to do a phase shift, because we need to start at January, or the highest part, and then plus our 12.415, conveniently placed there with the midline at the end. Nice. Okay, so then again, this part right here that we got to figure out, question mark. So that has to do with the maximum, not the minimum. So it's not going to be January in this case, because the maximum is where cosine starts, the function starts. And so in this case, the maximum is actually at 18.83 hours. And so we actually want to use that 7. So the x value goes here. So the x value of the y of, try to memorize this. So the x value of the y max value, right? And so the y max value is the 18.833, or 18 hours, 50 minutes. And so the x value that goes with that is July. And so, which is July, and July is the 7th month. So we are going to go ahead and put not a 1 on this problem, it's actually going to be a 7. Okay? That one's supposed to be rad, you wiener. Sorry. Okay, so that's where that one is. So there's the function now. Beautiful. Okay, so sketch the graph that approximates the daylight hours for the year. On the axis, let January be 1 and February 2 and so forth. Cool. So now we're going to sketch that graph. And again, our minimum was 6 and our maximum is 18.3. So minimum was 6 hours. Maximum was 18.83. And that's going to be our hours of daylight. Right? That's what it says in the problem. That's going to be the hours of our daylight. Awesome. And then we're going, so we are starting in January. That's important to note. All the way to December. Nice. And we're even maybe back to January. Yep. Okay, beautiful. Okay, so then let's see here. So we are starting, so our middle is going to be July. That's 7. And that's going to reach our 18.83. So we'll go and put a 7 right here, which is phase shifted tremendously actually there. Interesting. So that phase shift is going to affect things. We should probably put that in our calculator just to make sure when we graph this sucker, right? Because it looks like it's going to go something like this, starting in July and then hitting the 7. Too high. Make it flow, new build. Make it flow. Yeah, and maybe back there. Won't judge you. Don't judge me. Yeah, probably even the 13 is where it's going to repeat and be back down to that 6 there. Cool. Okay, so we'll take a look at our graph there. Again, our maximum should be at 7. Cool. Okay, let's just double check and plug it in there because we will need to do this for the next questions anyways. So go to y equals. Awesome. We're going to go and type in the 6.415 cosine. You can do pi divided by 6 if you want to. I really like the 2 pi. Just nice and neat. So we're going to need 2 parentheses. Don't forget that. So 2 pi divided by 12, good. And then another, and that's close parenthesis, open parenthesis. We're going to times that with our x minus 7. With our phase shift for this problem, having a peak in July, not June. Awesome, because that's the shift, right? You're shifting over 1 because of January, and also the peak is in July, not June. And then we're going to close one more parenthesis there. And then we'll go ahead and add our midline, which was 12.415. Beautiful. Now when we graph it again, it's not necessarily going to work because we got to check ourselves before we wreck ourselves. We got to do the window. And so we are going to start at 0 maybe in January all the way up to 12 or maybe even 13. And then our y will start at 0, even though 6 is our minimum, and go all the way up to 18.83. Well, let's go up to 20. And there's our graph. Beautiful. Beautiful. So you can already start to see the phase shift, that it starts to increase again because we're starting in January, not December, right? So that's why we have that phase shift of 7, because it pushes us over away from the 0, the December, over starting in January. That's what the phase shift is for. Cool. So looking good to me there, looking good. Okay, so how did the recorded daylight hours for April compare to your graph? So do you remember what month April is? January, February, March. April is 4. Good. So we're going to go to our graph, and we're going to do second calc value, which is option 1, and then type in 4 for April. Boom. It tells us 12.415. So we get number of hours, 12.415, and that's for April. And that's with our function. How does it compare to your equation? So we need to look at the recorded daylight now. So we go up to recorded, and it tells us in April it was actually 13:20. So that's going to be wow, that's going to be an hour more. And so let's convert. So the recorded value, right? So the recorded value was 13:20 minutes. And so that's actually going to be 13.20 divided by 60. It's 0.33333 repeating. Yeah, so that's how much difference there. We can even do a difference just to be really exact on the test. That'd be freaking awesome. So we're going to go ahead and do 13.33, the recorded amount, minus 12.415, which is our function amount. There we go. So we get 0.915. So we're actually not that far off, right? And so if we actually even times that by 60 minutes, that'll tell us 54.9 minutes. Cool. So we were only off by, right? So we were only off by 0.915, or 54.9 minutes. So yeah, so our function wasn't too far off of what the predicted amount, the recorded amount was for that year. Because remember, our graph is like on average. So you don't have to do part E. Lucky, you don't have to do part E. Cool. So then, there we go. And then I'm going to pause, or you pause me for a second, because I'm about to reveal the answers for number 3. So you try number 3 now. Try number 3. Try it. You try it. No, you try it. No, you try it. Try number 3, and then I'll reveal the answer. Pause me. You try 3 first. Okay. So let's see how you did. Got an amplitude of 1.615, a midline of 12.135. Is that what you got? Within a 12-month period. So our function, 1.615 cosine, 2 pi over 12, x minus 1 this time, because this time, so January equals 1, and this time our maximum y value, because they live on the other side of the world, Africa, so they have more daylight hours in January as opposed to us. And so, yeah, so we have a maximum, so that's why we're going to use 1 from January. That making sense? You sure you're getting it? Come see me for help. Watch more videos. There's our graph. Did you get that right for your graph for number 13? And then how did October, x equals the 10, which is interesting, it actually is the same as our midline. What? Compared to the recorded result. This is very close. Very, very close. 12.33 was the recorded. And then we plug it into our calculator, x equals 10 October. Do that function, we get 12.135. So thanks again for watching. Thanks again for watching. Peace out. Woo!